2.2. 2.2, we're going to graph some quantitative data, right? So we're going to graph some numbers. We're going to learn about stem and leaf plots. You could also just call it a stem plot. So I'll probably call it a stem plot. Same thing as a stem and leaf plot, okay? We'll look at dot plots. We're going to graph qualitative data, so we can use pie charts and Pareto charts. And then we're going to graph paired data sets using scatter plots, right? So if I have something where we go over time, and we have like maybe a distance over time, you know, if someone was trying to say swim around Great Britain, we'd be able to graph their distance over time. Yeah. In the statistical world, I'm not sure why this word is being used. We're not going to call it that, even though it's going to, everywhere we see that. And in your text, I'm going to call it a histogram, okay? Oh, I spelled that right. Yeah, I did spell it wrong. There's an O there. So, I had a feeling something was wrong there. Histogram. Histogram? I guess I just pronounced it weird. So in your text, you'll see it's called a Pareto chart. I don't even know. But maybe it's named after the person who invented it. In formal statistics, it's always and forever called a histogram. So I want to make sure that if you were to get a question on the ACT, SAT, if you were to take some sort of standardized test and it asks you for a histogram, you know what it's talking about. Alright? So, right now. Okay, quantitative data sets with the stem and leaf plot. We take each number and we separate it into a stem and a leaf. It is similar to a histogram. It still contains original data values. All right. So how does this work, right? We've got this 21, okay? That's 21. See that? $25. Where's the 25? There are two of them. We have one 25 here and another 25 there. That's what they look like. So I'm going to correct that. Sorry. Not histogram. You've heard this called a just a regular bar graph. Yeah, sorry. I believe this one is going to be used to this one is going to be used to graph qualitative data, while a histogram graphs quantitative data. So, okay, ooh. Let's make one. Here we go. We got the number of text messages sent last week by the cellular phone users in one floor of a college dormitory. Display the data in a stem and leaf plot. I'm going to give you guys a moment to write these numbers down.
Like 100 on the left, or just 1 on the left?
So the rule is, okay, your leaves can only be one digit, right? So would it make sense to just put for a 144, to put just a 1 on your stem, right? It wouldn't make sense, because then you would have 2 leaves, right? So you have 2 options. You can either round, and then you'd only have 2 digits, right? Or, so you could round to the tens place, right? then you would only have 2 digits. Or you could make your stem 2 digits. That is okay. Right? It's okay to make your stem 2 digits.
That's like the first one, like 15, and then on the other side, the right side would be 9.
Exactly. All right, so you'll see. I just got saying, right? 78 is going to be represented by a stem of 7 and a leap of 8, right? But 159 is going to be represented with a stem of 15 and a leap of 9. And let's see what that looks like. So, this is important. You have to include a key, all right? Including a key is like including labels on a graph, right? It's absolutely necessary. You don't label graphs, they're not right. And so a key is absolutely necessary. Also, I like this much better. Let's order them. It's much easier to sort through the data when it's been ordered properly. Yeah, exactly. You can kind of figure out kind of where the center of it is, right? Where your median or your mean are, which we'll talk about here in a little bit. You can look at the shape of it, right? It looks like, you know, maybe on average, or you could say the majority of text messages sent was somewhere between 100 and 140, right? The majority of our text messages sent. It's much easier to look at the data when it's been ordered properly. All right, so let's construct one ourselves. All right, so let's talk about it first. Let's see if we're going to have room. The ages of the 50 richest people. So first of all, make our line. What is our smallest step? Smallest step. 3, right? Yeah, it looks like. Are there any 20s in there? No. No 20. So we got a 3. Okay. Of our 3s, how many have we got? Oh, yes, they put this in order for us. Whew, that makes life so much easier. So then we can put a 5 and a 6, right? So we got 35, right? That's the first one. And then 36, right? See how that works? Sorry about that. Yep. Our next one is going to be 4, right? That's our 40s. So it's 35 and 36. Yeah. And now we're going to do 40s. We've got a 42. So that's that one, right? We've got a 43. That's that one. You see how we're going? 44, 46, 47, and 49. No, it's okay. You guys are getting the hang of it. All right. Did we finish the 40s? 49, yes. Let's go through the 50s. So we got 51, and then like you were saying, right, 51. We've got a 53, and then we've got another 53. A 54. We've got two 54s also. We have a 55, no, right? We've got a 56, a 57, a 58, and a 59. Now we're on to our 60s. And so how do we represent 60? By putting a 0 there, right? And then we have a 61, a 61, a 63, 64, 65, 65, 66, 66, 67, 68, and 69. And another 69. Because that represents 60. We can't leave it out or else we won't know that that number's there, right? Yeah. I know, usually 0, like, if you were adding, if you said 1 plus 0, right, the 0 would just go away. But not in this case, because the 0 doesn't represent nothing. It represents the ones place in the number 60, right? So it's got to be there. All right, 70s. We got 72, 73, 73, 73, 76, 77, 78, 78. You guys writing this down? All right, the last step is going to be for 80s. So 80 is going to be represented by a 0 right there. 1, 2, 3, 83. Sorry, I should write. I should be saying it. Here's an 85, 86, 86, 87, 89, and 89. All right, cool. All these numbers are well and good, but let's put them back into context. What was this? This was the ages of, what was it, the 50 richest people? What does this data tell you about the 50 richest people and their ages?
How many people there are? 60.
Huh? It does tell you that there are 50, the 50 top ones. There are 50, but yes, it seems like there are more people, more of the richest people are in their 60s. And overall, it seems like it takes a little while to get rich. Right? It seems like the richest people tend to be older. Actually, like retirement age and older, right? So it takes a little while to accumulate wealth. Oh, and there it is. We made that. Beautiful. And it seems like the richest people are over 50 years old, which is kind of what I didn't write my key. Mine was wrong. I got so caught up. So let's make our key. I'm going to say 5/1 represents